Welcome, my student, for the lecture in mechanism of inorganic reactions. What is reaction mechanism? Simply giving a details for the reaction pathway using step-by-step analysis. Let us say sequence of reactions involved in the conversion of reactant to product, then the rate law. We may define stability of complexes according to two systems, kinetic and thermodynamic. A labile mean the ligands are easily substituted, but inert ligands are not easily substituted. In thermodynamic, stable and unstable. Unstable for easily substituted. So, K formation for the reaction is of a large value. Stable for K value is small. Kinetically, we may follow the reaction by several techniques. Thermally, by calorimetry, potentiometry, spectrometry, using NMR or ESR technique. Columnity as analytical way. So, kinetic asks how fast. Kinetic asks about the time to reach equilibrium. Labile compound, that is mean rapid substitution of one ligand by another, T have less than 1 minute, while inert compound does mean substitution process is very slowly or not at all, T have more than 1 minute. Thermodynamic ask how far. Thermodynamic ask about the beginning and terminating. So, it followed the concentration of reactant and the product. Calculation of K equilibrium at the end of the reaction. See these examples. 1. The following reaction Hg plus 2 plus Cn minus K formation is 10 to the power 42. So, with respect to formation of this compound is stable. High K formation. But the compound undergoes another reaction, substitution reaction with cyanide. Experimentally using carbon 13, the reaction will happen rapidly, so it is an unstable compound and labile. This compound is thermodynamically unstable with respect to its reaction with activated cyanide. In addition to that, it is kinetically labile. Example 2. Let us see the below table. See, this K formation is a high values, so it is a stable compound with respect to formation. But when study the substitution reaction of these complexes, the first one is labile, very fast. The second compound is in the medium, So it is depend on the reaction, other reaction conditions. The last two reactions are very slow, so it is inert compound. Example 3. NCl3 alone decomposed, so it is unstable. But decomposition of NCl3 take a long time, so it is inert. Example 4. Hexaamine cobalt 3 react with water. K equilibrium is 10 to the power 64, so it is unstable compound. But kinetically it is inert because cobalt is D6 compound with low spin orientation, so it is inert. Cobalt 2 react with water, so it is unstable. Then cobalt here is D7, so it is a labile compound. Let us see this reaction. Hexaamine cobalt 3 in acidic solution. This compound could be saved to several weeks in acidic solution without any change, so it is inert. But delta G is minus, so it is thermodynamically unstable. Let us see this reaction. Silicon tetrachloride or tetrachlorosilane alone thermodynamically stable, shows a resistance toward dissociation. But tetrachlorosilane in water decomposed to SiO2. With water dissociates, so it is thermodynamically unstable and kinetically labile. Let us see this compound, CCl4, carbon tetrachloride, in the same group of silicon, but as we know, carbon tetrachloride with water is immiscible solvents. So we say carbon tetrachloride is stable. Show a resistance to the word dissociation, but is kinetically inert, but for a long time it undergoes dissociation, so it is thermodynamically unstable. We may study this reaction according to activation energy. So silicon tetrachloride of a small value of activation energy, and this product is of a lower level, so the reaction happen. But carbon tetrachloride of a high activation energy. So thermodynamic and kinetic may differ from each other in the description of reaction rate. Thank you.